All right, can someone give me an example of a substituted hydrocarbon? I think that's what it says up there. Yes. Okay, that would be a halogen derivative. So what's another derivative? Well, I mean other than a halogen derivative. Okay, if you're going to form a ketone, yes, oxygen does that. Okay, an alcohol, that would be another derivative, and both of those are organic families. Ketones you're not responsible for, but alcohols you are. Okay? There are simpler ones. The first two that we discussed this chapter are what and what. The simplest two derivatives that we've talked about, the first ones of this chapter. No. Nope, you're giving me actual alkanes. What is derived from alkanes?
I don't even know what an alkane is.
Excuse me. Alkane would be methane, ethane, propane, butane, pentane, all the way up to decane. Those are alkanes.
Okay. So, what was the question again?
The simplest and first derivatives we discussed this chapter.
Okay.
Those are organic families, not derivatives. That's an alkane. That's what we're asking you. So you said chlorine, the first one. That's a halogen derivative. In other words, that has replaced a hydrogen atom. Okay? So what that means then, okay, and the reason we take this slow progressive manner is once you hopefully gain a good understanding of this, some of you will be responsible for taking classes like this in college. And it will be horrible walking in to this without any background in it. Okay? What you see up here is actually quite complex, so we don't want to do that. Okay. So how about a multi-carbon alkane? Okay. So let's put to use what you've talked about so far. Right there we've got pentane. And should you write this down, you've got, that was the first derivative you said.
Chloride.
You've got 2-chloropentane.
Chloral, yep.
Okay? Then this would be chloropentane because it's just understood us on the first one. Okay? Then here you'd have 1,3 dichloropentane. Okay?
On the way you write, you could have that on top or underneath the carbon too. Like
What, chlorine?
Yeah, that chlorine.
Yeah, you can put it any one of these spots. Okay? So perhaps to answer this, let's give an isomer of this compound. In other words, we know we've got C5H12. So what would an isomer be? Because that's what it would appear that a lot of you struggled with the most. Okay, I'll write what the most common one that I had seen is this, an isomer.
Yeah. Yeah.
No, it is not.
Because it doesn't, it's not,
It's just bent. It's not a, okay, this is a straight chain. This is just bent. Your longest continuous chain is still 5.
now say that carbon was on the second one, then it would be.
Okay, if we move this over 1, then this is an isomer. Because what do we have now?
It's
It is. So we can write butane then. Is there anything branching off of that butane? Okay. So what do you suppose that is?
What is it called when it
C3.
say that was 2 carbons branched off of it? What is that called?
That's an ethyl group.
No, no, like you call it something if it's saturated or something like that. Saturated.
Saturated.
A double bond?
Double.
Yeah, like isn't that called like it being saturated?
Or that's unsaturated.
Oh yeah.
That is unsaturated because it has a double bond. Okay? So, what can we put inside this box for a structural formula for a methyl group? Is that right?
What was the filter?
I just wrote down what you told me.
No,
C2.
C2. No,
Okay.
C4, C4. No.
C4. Okay.
Tom said C4. Wait, Tom. They aren't right. C3.
C3. Okay.
That's what Brendan said. Alright, Brendan said this is wrong. It's on you.
Say that again. CH3. In other words, what's in the box there is in the box here. Okay? So this is no longer carbon to hydrogen. It is a what to what bond now. It's a carbon to carbon bond. Okay? When we did this, is that a carbon to carbon bond? No, it's not carbon to hydrogen. It is carbon to chlorine. So this is called a halogen what? Derivative. So what do you suppose this is?
A halogen? No.
It is also a derivative. Okay, it's actually called an alkyl derivative, but you don't need to know that. But that was the first derivative we learned, correct? Yeah. Because this might look familiar. We said if you want the symbol for that element, you would say, is that right? Okay, is that right? Well, it must be this then. They all have the same letters in common, right? So what is the symbol for iron? And why do we call Fe? Because it is derived from Latin for iron. So when we say a derivative, CH3 is derived from CH what?
4.
CH4, which is called what? Methane. Okay? And now we've got what?
You have
Ethane. Okay? So, back to where we were. Again, a lot of the mistakes that we see is people are putting down bent chains for isomers, which is not correct. Okay. All right. So substituted hydrocarbons. Okay. Hydrogen is replaced by something else. It can be carbon, it can be chlorine, it can be oxygen. All of them which you gave are correct. Okay. And we gave examples of these. Now we're talking about them. I believe you must have wrote them down. Okay? Now, this was another common mistake. And what do we say about mistakes? Okay? Try to learn from them and try not to repeat them. Okay? So, give me a hydrocarbon chain to name an acid. Give me an alkane first.
C. Hexane.
Hex.
C4.
Which one?
H.
Did you say heptane or hexane?
C4H10.
Okay. So if we're going to make this a 7-carbon acid, okay, a lot of you, what you did is you may looked at your materials that we talked about in class and then looked at this and then said, oh, well, we know it is a COOH group. Okay? Is that heptanoic acid? No, it's an acid, but which one? It's octanoic acid, okay? Because you can do this, but this is not how we taught you to write this down. What did we do instead?
We put a double bond between oxygen and carbon, and then it's linked with OH.
Now you have heptanoic acid, okay? So, and I don't know how we fix that, whether it's, are we going too fast?
Yes.
We are. Okay? So what needs to be gone over again?
Stuff like that.
Okay? So the explanation?
Yes.
So what don't we understand about this?
How we figured it out.
You got
Okay? So what does your handout say when it says organic acids? What does it say? What you said, okay, I'm trying to see this from your point of view. You said this needs to be reviewed. So I'm going back to review what it was that you perhaps could have or should have wrote down. So what would that be? Where is your handout? Because are we doing what you asked? Are we? Oh, you've had enough. This isn't a debate or an argument. Okay? Do we want to go over this? Yes or no? We're here for your. I think maybe speak for other staff members is that I don't know. Maybe we do go too fast. Who really has a good understanding of this? Because this is not unique to just this class. No one has a good understanding of this. Okay? So with that, I'm going to hit the pause button. And do you mind explaining this to your classmates? Because maybe you can explain it better than I can. Okay? So I'm going to hit pause right now. How many times have we gone through and said, front row, do we understand? And what do we do? You nod your head, yes. So does this mean no? Okay. So front row, do we understand this? Okay. We don't need to go any further. All right. So maybe it's better to go in reverse. Make this just slightly more complex. Okay, so a couple things that we would hope that stands out in your mind right when you see this. Okay? So then, and I'm just going to ask this just for my own benefit. If we struggle with this and we don't understand it, are we helping ourselves by not writing it down? I mean, be honest, who's writing this down right now? Okay? So I'm just trying to understand this from your level. What can you tell me? Everything that you see so far.
It's gonna be sex.
It's going to be 6. Okay? Okay? So this tells you you've got 6 carbons. All right? So it must be fun doing this. All right? We know what you meant. Sometimes when your brain is trying to decipher what to say, you see something and then you say something that has the same letter in it. You know? Like, for instance, if you're going to say hi or wave hi, but you say hello, if you combine them, if you're thinking too fast, you might say hi-lo. You're waving hi, but you say hello, but you put the two together, you come up with hi-lo. That's what you just did. Okay? That would be a neuroscientifically way of looking at that. Okay? So this tells you have 6 carbons. Okay. What else? What is everything you can tell me about these 6 carbons? Okay. So you know you're looking at an acid if what happens?
Second carbon.
No. No. The
Well,
two-
you're saying the right things, but just not correctly.
The 2 is connected to the methyl group. So on the second carbon, there's going to be a methyl group.
Okay. So which side, the left or the right?
Doesn't matter.
Well, it doesn't matter to me either.
Left.
Okay. So here's our second carbon. What is branching off of that?
CH3.
CH3. You can write the molecular formula, which is this. That is a methyl group. Or if you want to do the structural type, you can do this as well. Those mean the exact same thing. Okay, so we've accounted for this. We've accounted for that. This specifically tells you something on the first carbon, which has to be this one now. What is on that first carbon? Because in your handout, it's going to say this. But that is a molecular formula. You can do that, but you really, really have to pay attention to what you're doing. Because when you see that, you said it earlier, but it was just not the correct order. Well, it's not that it was backwards, but you said something about an oxygen and an OH group, right? So what's significant about an oxygen? Okay, this one right here is a double bonded oxygen. It doesn't matter if you put it on the top, you can put it on the side, you can put it on the bottom. It does not matter.
How would you make it to where that the 2-methyl was a double bond, like the carbon on the second, you know? How would you make it to where that's a double bond?
Double bond here? There is no double bond there.
How would you write it if it was a double bond there?
XN.
Okay, can we finish this first? Okay. Are all these carbons single bonded between one another? Yes. Okay. And then to finish this up, what is on here? What do we have left over from this definition?
No, O.
Or OH.
Okay. That is now 2-methylhexanoic acid. Because this is telling you you've got 6 carbons with a COOH group on. There it is, COOH. Okay? This is telling you you've got a methyl group on the second carbon. There it is. Okay? So I don't know if it's a product of going too fast or I don't know. Again, we're just trying to understand this from your point of view. Can we close the books on this? Can we erase it?
Yes.
So do we understand this? First row. Second row. Third row. Okay, so we saw a couple of these and this, okay? So if we did struggle with this, somewhere around page 708, 709, getting into 713, it's got examples of alcohols, it's got examples of acids, it even shows you the reactions in here, and that's where this content comes from. It's just the idea that we really don't want to bog you down with too much information too quickly. So the content comes from here. You're always right if you look at this. So if whatever it is that how we're explaining it, if it's not working, maybe if you are a reader, take a look in the book where the original content came from. Okay. So, going back to, do you really want to know?
I mean, will it be on our test or anything?
No. You're not curious to the...
No, I was just wondering, like, but I don't need to know.
Okay, this is how I'm interpreting what you had asked. On that second carbon, is it possible if there's a double bond? Isn't that what we had said?
Yeah.
Okay.
Or how would you write it?
That's why I asked, are you sure you really want to know? Because we can name that now. Okay. Okay? So, what is your parent chain? Your longest continuous chain? It's still going to be 6. What is your organic family? That's the parent chain, not the family. It's not a... Did you say alkane? It's an alkene. Okay? So the prefix has not changed. Okay? Because now we have hexene. This double bond here is telling us we've got an alkene. Okay? Now, this double bond happens after the first carbon, but we've got this derivative on here. So we've got 2-methyl-1-hexene. That's way too complex for this level. That's why I said, are you sure you want to know? And one of your classmates said, yes. So now we know.
How come the dash, 1 dash? What does that mean?
That means that if we did this, we wouldn't need it. One, two, three, four, five. Oh, yes, we would. Okay. It's just understood as after the first carbon. But once you start adding a derivative on there that's also associated on that carbon, you have to put both of them, which is a senior level application. But asked and answered. Okay? Well, that leaves us with about only 10 minutes left. So, what do we have left on here? Alcohols and acids. Okay. I think we've covered this as well.
We covered.
No, we
No,
haven't.
you said not to write it down.
Oh, okay.
I wrote it down.
Okay, so once you have that wrote down, we will pick up with this tomorrow. Okay, can we,
No.
okay. We're being really, really studious. We're writing this down. Must be soaking it up. Okay? Soaking it up, right? Why is there a gap in there? How could you, we're sitting right here.
Probably just didn't doing it that day.
Oh, okay. How did that work out for you?
No.
Okay. Asked and answered. And I think we would perhaps agree that just like in the physics portion of this, if you had questions, if we're not writing things down as we go, you're not helping yourself. How can anyone else help you? If you're not going to help yourself, who else can help you?
Older classmates.
But you're not willing to help yourself is my point. If you're not going to help yourself, who else is going to help you? Nobody, probably. All right. We will pick up with this next time.